In this video, I'm just going to work through the problems in this final exam review. So let's just dive right in and get started. The first question just says to solve the equation. So what we need to do is we just need to do some algebraic steps to isolate the y variable on one side and everything else on the other side. The first step here would be to distribute that negative 6. So that will give me negative 12y minus 18 plus 6 equals 24. I'll combine the negative 18 and the 6. Negative 12y minus 12 equals 24. Then I will add 12 to both sides, which gives me negative 12y equals 36. And then I will divide both sides by negative 12. And that gives me y equals negative 3 as my answer. Coming down here to number 2, it says to determine whether the equation is conditional, an identity, or a contradiction. Conditional would be where it simplifies down to just one solution. An identity would be where it simplifies to something where you have exactly the same thing on the left side of the equal sign as the right side. And a contradiction would be where the two sides of the equal signs are different, right? So you have something equals something else that's not equal to it. Conditional means one solution. Identity would mean an infinite number of solutions. And a contradiction would mean the equation has no solutions. So let's get started. What we're going to do here is begin by just combining like terms on the left. So y plus 3y gives me 4y. So 4y minus 8 equals negative 2y plus 4. Then I will add 2y to both sides. That gives me 6y minus 8 equals 4. Then I'll add 8 to both sides. So I get 6y equals 12. Then I'll divide both sides by 6. And that gives me y equals 2 as my final answer. And because it's a single solution, that means it is conditional. Let's come down here to number 3. It says to solve the equation. So this is an equation involving fractions. So to solve this, what we're going to do is we're going to find the least common denominator. The least common denominator will be the smallest number that all 3 of these denominators will evenly divide into. Okay. So the smallest number that evenly divides 2, 3, and 5 would be 30. So I'm going to take every single term in this equation and multiply it by 30. So here's what that looks like. I've got 30 times 3x minus 2 over 2 plus 30 times 5x plus 4 over 3 equals 30 times 37 plus 7x over 5. Now I can just divide out all of the denominators. Over here, 30 divided by 2 is 15. So I get 15 times 3x minus 2. Here, 30 divided by 3 is 10. So I get 10 times 5x plus 4. Over here, 30 divided by 5 is 6. So this is 6 times 37 plus 7x. Okay, so now I have a new equation with no denominators, which makes it easier to solve. What I'll do is I'll distribute. So I'll distribute the 15 right here. That gives me 15 times 3 is 45. So 45x minus 30. Then I'll distribute the 10, which gives me 50x plus 40. Then I'll distribute the 6. 6 times 37 is 222. 6 times 7 is 42, so that becomes 42x. Okay, on the left, I will combine like terms. So let's see here. Right. It looks like, let me just double check. So minus 30, 50x plus 40. Okay, so 45x plus 50x is 95x. Negative 30 plus 40 is 10. Now over on the right, I have 42x plus 222. Okay, so what I'll do is I will subtract 42x from both sides. Okay. So 95 minus 42 is 53, so I get 53x equals 212. And then I divide both sides by 53, so I get x equals 212 over 53. That's my final answer right there. Okay. Okay. Now here to number 4. If the sum of two numbers is 65, and the larger number is 3 less than 3 times the smaller number, find the smaller number. Okay, so let's set it up this way. Let's say that x and y represent the two numbers. So we can say x plus y equals 65, right? They add to equal 65. Then we can say the larger number is 3 less than 3 times the smaller number. So if x represents the larger number and y represents the smaller number, then that would be x equals 3y minus 3, right? 3 less than 3 times the smaller number. So I can treat this as basically a system of equations, and I can solve this using the substitution method. This equation here is solved for x, so I can substitute it into the first equation. So that gives me 3y minus 3 plus y equals 65, right? I just took the first equation and I replaced the x with 3y minus 3. Combining like terms, 3y plus y is 4y. 4y minus 3 equals 65. Add 3 to both sides. I get 4y equals 68. Divide both sides by 4. 68 divided by 4 is 17. Okay, so there's one of the two numbers. To find the other number, we would take y equals 17 and we would plug it into this equation right here. So I would get x equals 3 times 17 minus 3. And that works out to be 48. Okay. So those are my two numbers, right? The larger number is 48, and the smaller number is 17. Okay. All right. Coming down here to number 5. solve the inequality. Write the solution set in interval notation. So we'll begin by solving it in a similar way we would solve an equation, right? We'll just do some algebra to isolate the variable on one side. I'll begin by distributing the negative 2 on the left. That gives me negative 8y plus 14 plus y. Then over here I have 2y, and I'm subtracting negative 10 plus y. Subtracting in this case, we could think of it as adding the opposite. So I'll do a plus, and then I'll change the opposite of negative 10 plus y would be 10 minus y, right? You change the sign of each individual term. So it becomes plus 10 minus y. Okay. Now I can combine like terms on the left and the right. So on the left, I get negative 8y plus y, which is negative 7y plus 14. On the right, 2y minus y is just y. So I get that. Now I will subtract y from both sides. So I get negative 8y plus 14 is greater than or equal to 10. And then I will subtract 14 from both sides. Negative 8y is greater than or equal to negative 4. And then I need to divide both sides by negative 8. But this is one important rule, just to remember. When you're solving an inequality, if you end up having to multiply or divide both sides by a negative number, then you have to flip the direction of the inequality sign. And that is something we have to do in this case because we're dividing both sides by negative 8. So I end up with y, flip the direction, and I get negative 4 over negative 8. Of course, negative 4 over negative 8 simplifies into 1/2. So it's y less than or equal to 1/2. Using interval notation, I would write this as negative infinity, comma 1/2. And I would put a square bracket there, which communicates that the endpoint 1/2 here is included in the interval. I know that because this is y less than or equal to 1/2. So that would be my answer in interval notation. All right, coming here to number 6. Determine if the ordered pair is a solution to the linear equation. To determine if it's a solution, we just replace x with negative 9 and y with negative 3, and then we see if it gives us a true statement. If it's true, it's a solution. If it's false, it's not a solution. So doing the substitution, I get 6 times negative 9 minus 5 times negative 3 equals negative 38. 6 times negative 9 is negative 54. Negative 5 times negative 3, that's plus 15, equals negative 38. Negative 54 plus 15 is actually negative 39. So I get negative 39 equals negative 38, which is clearly false. So that means this ordered pair is not a solution. Okay, number 7. Find the x-intercept and the y-intercept, and then graph the linear equation using the intercepts. The x-intercept, that would be where the graph crosses the x-axis. When it crosses the x-axis, that corresponds to a y value of 0, right? So to find the x-intercept, I would replace y with 0 and solve for x. Let's go ahead and do that. We'll just say set y equal to 0. That gives me 3x minus 5 times 0 equals negative 30. 5 times 0 is just 0, so this becomes 3x equals negative 30. And then divide both sides by 3, so I get x equals negative 10, or as an ordered pair, that would be negative 10, comma 0. And that would be this point right there. That's the x-intercept. The y-intercept is where the graph crosses the y-axis. That is going to correspond to an x value of 0. So to find the y-intercept, I will set x equal to 0 in the equation and solve for y. Set x equal to 0. So 3 times 0 minus 5y equals negative 30. 3 times 0 is 0, so this is negative 5y equals negative 30. And divide both sides by negative 5 gives me y equals 6, or 0, comma 6, which is right here. Then the graph would be just the straight line connecting those 2 points, like so. All right, coming down here to 8. Use the slope formula to determine the slope of the line that passes through the two ordered pairs. The slope formula is y2 minus y1 over x2 minus x1. So you subtract the y values and you divide that by the difference of the x values. y2 minus y1, this would be 1 minus 5. And then x2 minus x1 would be 4 minus 4. 1 minus 5 is negative 4. 4 minus 4 is 0. So we end up with negative 4 over 0. Of course, you can't divide by 0, so this is actually undefined, which means that the line that passes through these points will be a vertical line, because vertical lines have undefined slopes. Okay, number 9 here. The height in feet of a ball that is dropped from a 140-foot building is given by this function, h of t equals negative 16t squared plus 140, where t is the time in seconds after the ball is dropped. Find h of 2 and interpret its meaning. Round your answer to the nearest hundredth. H of 2, this just means we take the function, and everywhere you see a t, you replace that t with a 2. So this becomes negative 16 times 2 squared plus 140. 2 squared is 4. Negative 16 times 4 is negative 64. Negative 64 plus 140 is 76 feet. The interpretation here is that the ball, remember the ball is being dropped from a 140-foot building. This tells me that after 2 seconds have passed, the ball is 76 feet above the ground. Okay. Ball is 76 feet above ground after 2 seconds. All right, coming down here to number 10. 2 cars are 170 miles apart and travel towards each other on the same road. They meet in 2 hours. One car travels 1 mile per hour faster than the other. What is the average speed of each car? For this, we will define 2 variables. Well, really just 1 variable, but we'll define x as the speed of the first car. We'll say speed of car 1. that means the speed of the second car is actually going to be x plus 1, right? Because the other car travels 1 mile per hour faster than the other car. We'll say this is the speed of car 2. So what we can do is we can take the speed of the two cars, x plus 1. So speed is measured in miles per hour. And if you take the speed and multiply it by the time, you get distance. So this is the sum of the speeds of the two cars. If I multiply this by the total time, that's going to give me the distance. And I know the total distance is 170. Okay? So I get this equation, which I can then solve for x. I can divide both sides by 2, and then I can also combine the like terms inside the parentheses. Combining like terms gives me 2x plus 1. Dividing both sides by 2 gives me an 85, because 170 divided by 2 is 85. Then I can subtract 1 from both sides, so I get 2x equals 84. And I can divide both sides by 2, so x equals 42. Okay, so 42, so the speed of car 1 would be 42 miles per hour. And the speed of car 2 would be one more than that, so 43 miles per hour. So those were the average speeds of the two cars right there. Okay. Number 11, solve the system of equations. We can solve this system using the substitution method. That would be the easiest method because this first equation is already solved for y. So I can take the second equation and I can replace y with 3x plus 5 and then solve for x. So I get 2x minus 5 times 3x plus 5 equals negative 12. I'll distribute that negative 5. So 2x minus 15x minus 25 equals negative 12. Combine like terms on the left. 2x minus 15x is negative 13x. I will add 25 to both sides, which gives me negative 13x equals 13. And I will divide both sides by negative 13, which tells me that x equals negative 1. Okay? That is the value of x. To find the value of y, I'll take x equals negative 1 and plug it into the top equation. So y equals 3 times negative 1 plus 5, which equals negative 3 plus 5, and that means y equals 2. That's the y value. Okay. Okay. Coming down here to 12, simplify the expression. Okay. All right, so first of all, the 54 and the 12 are both divisible by 3. So I can simplify that. Negative 54 divided by 3 is... I can go farther than that. They're actually both divisible by 6. So negative 54 divided by 6 is negative 9. 12 divided by 6 is 2. Okay, so that's how the numbers simplify. Let's focus on the a's. I have a to the 6 on top, and I have a squared on the bottom. Basically, 6 a's on top, 2 a's on the bottom. The 2 a's on the bottom can cancel with 2 of the 6 a's on top, which leaves me with 4 a's remaining on top, so that would be a to the 4th. And then we look at the b's. b to the 7th on top, b to the 10th on the bottom. 7b's on top, 10b's on the bottom. The 7b's on top can cancel with 7 of the 10b's on the bottom. That leaves 3b's on the bottom, so that would be b cubed in the denominator. Okay, so that's how this simplifies down. Subtract the polynomials and simplify. Subtracting polynomials is the same as adding the opposite. So the first polynomial is 7r cubed minus 8r plus 7. The opposite of the second polynomial would be the one where all the sign in front of each term is changed, right? So this becomes plus 5r cubed minus 4r minus 2. Now I can combine like terms. 7r cubed plus 5r cubed is 12r cubed. Negative 8r minus 4r becomes minus 12r. And then I get 7 minus 2, which is 5. So that's my final answer right there. 14. Multiply the polynomials using the distributive property. Simplify the solution. All right, so if we're using the distributive property, that basically means every term for the second polynomial here gets multiplied by the first one. So that looks like this. M squared times m minus 3n plus 7mn times m minus 3n minus 6n squared times m minus 3n. Then I can distribute. Oops, sorry. So this first one becomes m cubed minus 3m squared n. Then over here I get 7m squared n minus 21 mn squared. Then over here I get negative 6mn squared plus 18 n cubed. Then we should see if we can combine like terms. There's not any other m cubed terms. But let's see, I do have a negative 3mn squared right here, or sorry, m squared n. And then I have a 7m squared n right here. So 7 minus 3 is 4, so that becomes 4m squared n. And then over here I have negative 21 mn squared, and I combine that with the negative 6 mn squared, which gives me negative 27 mn squared, and then I have a plus 18 n cubed. There's my final answer. Number 15 says factor the expression completely. If the expression cannot be factored, then write prime. Okay, so what I can do is I can focus on the first two terms, and I can pull out a common factor from those. And then I can also pull out a common factor from the second two terms. That's how I would start. So from the first two terms, I can pull out a factor of x, and that leaves me with 7y minus 6c. From the second two terms, I can pull out a factor of 6c, and that also leaves a 7y minus 6c. Then that factor of 7y minus 6c can also be pulled out. So it leaves me with 7y minus 6c times x minus 6c as my answer. Okay. 16. factor the trinomial completely. If the expression cannot be factored, then write prime. So factoring this, we begin by taking the coefficient of the u squared term, and I multiply that by the constant term. So 5 times -1 equals -5. Then I identify two numbers that multiply to equal -5, but add to equal 4. Those two numbers could be 5 and -1. I use those two numbers to set up two what we call temporary factors. So I basically say u plus 5 and then u minus 1. Then what I do is I take the coefficient of the u squared term, which is the 5, and I stick that underneath those numbers in my temporary factors. Now, where you can reduce, you reduce. Where you can't reduce, you take that denominator and you move it out front. So this one reduces, right? 5 over 5 is 1, so that becomes u plus 1. And then this one, 1/5 doesn't reduce, so I bring the denominator and put it in front, and I get 5u minus 1. So that would be my factored quadratic right there. Factored trinomial. Okay, 17. Again, factor the expression completely. If the expression cannot be factored, then write prime. This can be written as a difference of squares. 64n squared can be written as 8n quantity squared, and 121 can be written as 11 squared. Anytime you have a difference of squares, something like a squared minus b squared, that factors into a minus b times a plus b. So that means this particular expression can factor as 8n minus 11 times 8n plus 11. Okay. 18. Solve the equation. We have r cubed equals 49r. I would begin by just putting everything on the left side of the equal sign. So r cubed minus 49r equals 0. And then I would factor out an r. So I get r times r squared minus 49. And then this is equal to 0. And then I can recognize that r squared minus 49, that's actually the same as r squared minus 7 squared. So we can factor also as a difference of squares, as r minus 7 times r plus 7 equals 0. So the equation has three solutions, and the three solutions would be the three values that make each individual factor equal to 0. So that would be r equals 0, because that makes this factor equal to 0, and then r equals 7, because that makes this factor equal to 0, and then r equals -7, because that makes this factor equal to 0. Those are the three solutions to the equation. Okay, 19. Multiply the rational expressions and simplify. Okay, so what we want to do is just factor where we can factor. So for example, the 5x minus 40 right here, I can factor out a 5 from that. So I get 5 times x minus 5. There's an x down here. And then the x squared plus 3x, I can factor out an x. So I get x times x plus 3. And then the 8x minus 64, I can factor out an 8. Okay. So now if there's any common factors on the top and the bottom, those can cancel. The only ones I see that can cancel is this factor of x right here, can cancel with that factor of x right there. Otherwise, we just multiply everything together. So 5 times x minus 5 times x plus 3. over 8 times x minus 8 is my answer there. All right. Evaluate without using a calculator. Express the answer as a fraction. So we have the cube root of negative 8/27. Could rewrite this as something like this: the cube root of negative 8 over the cube root of 27. Just apply the cube root to the top and the bottom separately. A cube root is a number that when it's cubed, you get the original number, right? So the number that you cube to get negative 8 would be negative 2, right? Negative 2 cubed is negative 8. So I get negative 2 on top, and then the cube root of 27 is 3, again because 3 cubed equals 27, right? So it simplifies into that. Simplify the cube root of 64, a to the 6, b to the 12. Okay. Oopsies, I don't need a root sign. Okay, so first of all, the cube root of 64 is 4, because 4 cubed equals 64. To find the cube root of the other terms, what you do is you just divide the power by the root. So the root is 3. The power here is 6. So 6 divided by 3 is 2. So this becomes a squared. And then here we have b to the 12. 12 divided by 3 is 4. So that becomes b to the 4. So that is what that simplifies into. All right. Solve the radical equation. To solve a radical equation, what you need to do is square both sides to eliminate the square root. So I square the left side, I square the right side. Okay. If I square the left side, I get 49t squared. If I square the right side, I just get what's under the square root, which is 49t squared plus 9t minus 10. And then I can simplify this. If I subtract 49t squared from both sides, I just get 0 equals 9t minus 10. If I add 10 to both sides, I get 10 equals 9t. Divide both sides by 9, I get t equals 10 ninths. Like so. Okay. 23. Solve the equation by using the quadratic formula. Okay, first of all, I need to set it up. So I'll begin by distributing the 2x right there. So I get 2x squared minus 4x. I'll bring the 5 over to the left. Okay. So this is in quadratic in standard form. Standard form looks like ax squared plus bx plus c equals 0. That means that a, in this case, is equal to 2, b is equal to negative 4, c is equal to negative 5. The quadratic formula says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If I plug in my numbers, I get negative b, which is 4, plus or minus b squared. Negative 4 squared is 16, minus 4 times a, which is 2, times c, which is negative 5, all over 2a. 2 times 2 is 4. Okay, let's see. This becomes 4 plus or minus square root of 16. Let's see, 4 times 2 times negative 5. This becomes, looks like 40. 16 plus 40 over 4. Okay, well, I'll have to come up here. So let's come up here. This is 4 plus or minus the square root of 56 divided by 4. The square root of 56, I can simplify that. Just do a little side note up here. Square root of 56 is equal to the square root of 4 times the square root of 14, because 4 times 14 is 56. Of course, the square root of 4 is 2. So that becomes 2 times the square root of 14. So this is equal to 4 plus or minus 2 times the square root of 14 over 4. I can factor out a 2 on top, so I get 2 times 2 plus or minus the square root of 14 over 4. And then that 2 can divide into the 4 on the bottom. So at long last, I get x equals 2 plus or minus the square root of 14 over 2 as my final answer right there. Okay, 24, simplify. To simplify, I need to simplify the radicals first. Okay, so let's start with 3 times the square root of 8. I could write this as 3 times the square root of 2 times the square root of 4, right? Because 2 times 4 equals 8. Of course, the square root of 4 is 2, so this becomes 3 times 2 times the square root of 2, which becomes 6 times the square root of 2. 5 times the square root of 18. This is equal to 5 times the square root of 9 times the square root of 2, right? 9 times 2 equals 18. Square root of 9 is 3, so this becomes 5 times 3 times the square root of 2, which equals 15 times the square root of 2. Okay, so 3 times the square root of 8 simplifies into 6 times the square root of 2. 5 times the square root of 18 simplifies into 15 times the square root of 2. And I can add these together, because now the roots are the same, so I just add the coefficients. 6 plus 15 is 21. This becomes 21 times the square root of 2, like so. Okay. 25, it says to rationalize. Rationalize just means to rewrite it so you don't have a root or a square root in the denominator. So to rationalize, what you do is you multiply it, in this case, by the square root of x over the square root of x. Right? It's a unit fraction where the top and the bottom are equal to the denominator here. That makes the numerator 3 times the square root of x, and the denominator down here, square root of x times the square root of x, is just x. So I've rewritten it so I don't have a root in the denominator. That's what rationalizing it means. Okay, 26. Determine if the following represent functions or not. The first two are just sets of ordered pairs. It's a function if all of the x values are different. It's not a function if you have any repeat x values, right? So we start with A. If you look at the 3 x values, they're all different. So that one is a function. Oh, sorry. I didn't mean to write that. A is a function. B, I see 2 ordered pairs that have the same x value. This one has an x value of 3, and so does this one. So that means that one is not a function. The other two are graphs. The way we test if a graph is a function is by doing the vertical line test. If you draw a vertical line and it intersects the graph more than once, it's not a function. You'll see this intersects the graph twice, so that means it is not a function. because it fails the vertical line test. This one, on the other hand, is a function, right? Because no matter where we draw a vertical line, it will never intersect the graph more than once. So that one passes the vertical line test. It is a function. Okay. 27, graph the following functions. So if this first one, we have 4 to the x power. I could do a little table here. Right? And maybe pick a few x values, maybe -2, -1, 0, 1, and 2. If I plug it into the function, this gives me 4 to the -2, which equals 1 over 4 squared, which equals 1/16. 4 to the -1 equals 1/4. This is 4 to the 0, which equals 1. And then 4 to the 1, which equals 4. And then 4 squared, which equals 16. If I plot these points, so when x equals -2, y equals 1/16, that's really close to the x-axis there. When x equals -1, y equals 1/4, a teeny bit higher, but still pretty low down. When x equals 0, y equals 1. When x equals 1, y equals 4. When x equals 2, y equals 16, that's going to be somewhere off the grid. So my graph looks like this. Right? It's an exponential growth function. Coming down here, I could choose maybe the same x values. So -2, -1, 0, 1, and 2. This first one gives me 1/4 raised to the power of -2. And what I could do is flip the fraction upside down and change the exponent to a positive. So this is 4 squared, which equals 16. 1/4 to the -1 power equals 4 to the 1 power, which is 4. 1/4 to the 0 power equals 1. 1/4 to the 1 power equals 1/4. 1/4 squared equals 1/16. Okay. When x equals -2, y equals 16. That's somewhere off the grid. When x equals -1, y equals 4. That's right there. When x equals 0, y equals 1. When x equals 1, y equals 1/4. When x equals 2, y equals 1/16. So this graph looks like this, and that is an exponential decay function. Okay, 28. Find the center and the radius of the circle. So the standard formula for the equation of a circle looks like this. X minus h squared plus y minus k squared equals r squared. H and k are the x and the y values of the center, and then r is the radius. If I compare my equation to this, I can actually rewrite it to look like this. X minus -5 squared plus y minus 3 squared equals 8 squared, right? Because 8 squared is 65. So h equals -5, k equals 3, r equals 8. So that means the center of my circle would be -5, 3, and the radius would be 8, like so. All right, 29. We have a logarithmic function here. Let g of x equals log base 3 of x. It says find g of 81. G of 81 equals log base 3 of 81. And the answer to this would be the exponent that you apply to 3 in order to get 81, and that would be 4, right? Because 3 to the 4th power equals 81. Then it says find g inverse of 0. So for this, we first need to know what is the inverse function. An inverse function is one where the x values become y values become x values. So my original function is y equals log base 3 of x. And what I'm going to do is interchange the x and the y values. So I get x equals log base 3 of y. And I want to solve this for y. Solving this for y involves writing it in exponential form. So I have a base of 3. Right? This is my base, and this is my exponent. So y equals 3 to the power of x. That is my inverse function. G inverse of x equals 3 raised to the power of x. So G inverse of 0 is 3 raised to the power of 0, which equals 1. Okay? Because anything raised to the power of 0 equals 1. Okay, 30. Solve log x minus 1 equals 2. Solving this will require rewriting this in exponential form. So it gives me x minus 1 equals 10 squared. If you have a logarithm where the base is not written in, it's assumed to be a base 10. We call that a common logarithm. Okay. This becomes x minus 1 equals 100. Add 1 to both sides. I get x equals 101 as my solution. 31. Find the inverse of h of x equals negative 3x plus 6. To find the inverse function, you begin by replacing the function symbol with y. So I get y equals negative 3x plus 6. Then I interchange the x and the y. So x equals negative 3y plus 6. And then I solve the new equation for y. So I can do that by subtracting 6 from both sides, and then dividing both sides by negative 3. But then I finish by replacing the y with the symbol for the inverse function, which in this case would be, we're using an h, so we'll do this little superscript, negative 1. We call this h inverse of x equals x minus 6 over negative 3. 32, write the following as a single logarithm. Okay, so I got to go through a few steps here. First step is I'm going to take all the coefficients and write those as exponents. So I'll write this as ln of 5x cubed plus ln of x squared plus ln of 3x quantity squared minus ln of yz to the fourth. This is equal to ln of 5x cubed plus ln ln x squared. Just confuse my notes for a minute. Okay, so then here, 3x, the whole thing is squared. I can write that as, so 3 squared is 9, and then x squared, so it becomes 9x squared. And then over here, I can apply that exponent to the y and the z individually. So I get y to the fourth, z to the fourth. Okay, so moving from left to right, I'm going to start consolidating. When I have a sum of two logarithms, I can bring those together using the product rule. So this gives me ln, and inside the parentheses, I'll have the product, 5x cubed times x squared. You add the exponent, so that becomes 5x to the fifth. Okay. Okay, now I'll take the next two. I'll take the this logarithm and combine those together. Again, because we're adding, that means we multiply. So 5 times 9 is 45. X to the 5th times x squared is x to the 7th minus ln y to the 4th z to the 4th. And then finally, the last two logarithms can also be combined. This time I use the quotient rule because this is a minus sign there. So this becomes ln of 45 x to the 7th. Let me just do a better job with that. So 45x to the 7th over y to the 4th, z to the 4th. And that's my final answer right there. Okay. Okay, last problem here. The value of a $3,000 computer decreases about 30% each year. Part A, write a function for the computer's value. Does the function represent growth or decay? So the function would be v of t. I put the initial value of the computer, which is 3,000. Then parentheses, I do 1 minus the growth rate. The growth rate is 30%, but in decimal form, that's 0.3. And then I'll do raised to the power of t. Or we can go ahead and simplify the inside of the parentheses and write this as 3,000 times 0.7 raised to the power of t. This represents a decay function, right? Because the number inside the parentheses, the base, is a number that's less than 1. Okay. Use the function to predict the value of the computer in 4 years. This would be v of 4. This equals 3,000 times 0.7 raised to the power of 4. Now, on an exam, if a problem like this appeared on the exam, you could just leave this as your final answer because we're not doing calculators. But since this is not an exam, I went ahead and plugged this into my calculator, and I got $720.30. Right, so that's the predicted value of the computer 4 years later. All right, and that wraps up this final exam review. I hope that was helpful. Thanks for watching.